ships are equipped with this equipment, and the forecast gives us 150,000 ships that should be equipped in 2030. Why collecting AIS from space, AIS signals from space? This will enable to offer a permanent worldwide coverage of access of AIS data. This will enable to monitor offshore AIS signals because terrestrial infrastructure only enable to cover the shore today. And this will offer high integrity ships positioning information to detect the spoofing. This is an important point. The AIS message transmits ship's positioning, and if a boat transmits a wrong position, this will be detected by the processing of the satellite. Now the question is why, which kind of use, or what is the interest of collecting AIS system from space for the users? In order to clarify this point, let's have a look on this video. So this is a typical maritime situation with one ship that transmits its AIS signal. This AIS signal transmits latitude, longitude, the ship designation, the origin. And this signal will be captured by a satellite that will receive the signal, transmitted then to a receiving ground stations. And these ground stations will forward the information to a mission center. There are many gateways, and all will centralize the information to the mission center. Now, what happens in the mission center? They receive the information worldwide, and they are able to trigger services like navigation hazards, pollution, sea resources management, illegal fishing, illegal immigration, trafficking, smuggling, terrorism, piracy, natural disasters, and safety at sea. So this is a situation when there is just one ship. But the problem is that the real situation, there is not one ship, but there are many other ships, and all transmit at the same time. And thus, transmission at the same time will create saturation of a standard AIS satellite. Here we see the standard AIS satellite. By receiving too many signals at the same time, the receiver will saturate. But with the Thales solutions that offer flexibility, antenna beamforming, we will be able to discriminate all those signals. And this will enable to have high probability of ship detection, high reliability, integrity, worldwide coverage, and at least to answer to the user needs. So European needs high performance, and of course we will show that we are able to deliver this services, these performances. So let's come back now to the presentation and to see more in details how we can achieve those performances. So I skip this section because I think that it's quite clear what is the problem we have to solve. And now let's go a little bit more in detail about the solution itself. Capturing AIS signal from space is challenging because of this issue of decolliding the signals. We see here a quantification of the problem. There are around 50 or 100 or 150 messages per slot that need to be decollided. And we see that because of this difficulty, the today state-of-the-art AIS solution do not offer the expected quality of service that are expected by the end users. Fortunately, we will see that with there are solutions for that, and I let the floor to Thibaut Calmette, the technical responsible, to give you more details.
So just to come back on the picture on the right, just to add that the value here is an average per minute. It means that we may have 200 signals received per slot on 2 channels, so in average 100 per slot, during an average over 1 minute. So it means that an instantaneous value can be much more, such as 500 slots on the 2 channels. Typically, as signals are received only on 2 channels and with the same frequency and the same date of arrival, we have no real separation capacity unless the space and direction of arrival capacity. So if we consider, as Remy has said, a state-of-the-art constellation with a mono antenna and single processing satellite, that is typically take a ship receiver and have it on a satellite, we will see that we will be easily able to detect in low density areas because the link budget is very favorable, but that we will have holes in the dense areas and in surrounding areas that are saturated by the dense areas. So there are 2 options to try to increase this performance. The first one is to have a larger constellation. The interest is to have better probability to come to a dense areas with a good direction and track, and having both a low density areas and the beginning of the dense areas at the same time. So it means that it is possible to reduce the size of the low density of the non-detection areas, but still with more than 60 satellites, the detection capability is not improved enough, and we still have holes on Atlantic and the most critical dense areas. The other solution is to improve the processing, taking benefit of the direction of arrival of the signals. And here we see that with the same number of satellites than in the figure above, we can reduce nearly all the non-detection areas. So what is this kind of improved processing? The idea is to use adaptive antenna processing. So antenna processing, the idea is to have not only 1 but 4 or more antennas, or even 2, but at least 4 antennas to have a correct performance to digitalize the signals and to perform what is the characteristic of adaptive beamforming, that is to, before applying the beamforming, to analyze the situation and to identify which beamforming would be optimal for the resolution of collisions, that is which beamforming is optimal both to improve the detection on the interest signal and to reduce the detection on interfering signals. So after this antenna processing step, there is a list of signals opportunities that have to be processed by a single processing. So first step of analysis to identify which kind of demodulator would be the best fitting the situation, and then a battery of demodulators that are selected or used in parallel or following, or only one, depending on the situation, to demodulate the message. All this process can produce false alarm. So there's, after that, a step to reduce the volume of false alarm and to make so that the message that are transmitted to the final processing are the most reliable as possible. And in the message management that is currently developed under RTS20 Data Processing Center for ESA by CLS and with Thales Alenia Space as a main subcontractor, it is possible to manage the messages, to evaluate the location of the ship and to verify that they have not taken the position that is in the message, and to store and archive and transmit all this data to the operational centers, as Remy has shown in the pictures. Just one point to add that the provision of satellite AIS is not only a matter of detection capability, because it's usually what is the most said, that is how it is possible to solve collisions, but AIS, satellite AIS, shall be an operational program and operational service, because it is applied for operational use and piracy actions and so on. So here is the list of everything that has to be checked. That is from reliability, availability, detection capability, performances, security, quality of service, and complementary services, and so on. So what is important to see is that our proposal and the interest of user is not only in a satellite that can detect everything sometimes, but really in a full service with a quality of service that is guaranteed.
Okay, so we have seen that by having high performance processing, we can provide a good quality of service, good detection probability. Now, let's talk about programmatic. How can we combine that high performance satellite with other systems? This combination, the recommended combination is quite simple. The idea is to combine the high performance satellite with existing commercial satellite AIS system coming from Opcom, Comdev, or others, in order to offer high detection on one side and high revisit time on low density areas on the other side. Thanks to this complementarity, we'll be able to provide a cost-efficient solution with high performance. So we can, of course, quantify this high performance. We see that with one high-performance satellite, we significantly increase the detection performance compared to 20 low-performance satellites. And of course, a combination of both are quite impressive in terms of detection. But there is still interest of having those 20 other satellites, because this offers the revisit time on low density areas. And of course, if we talk about incremental approach, with the first phase with one hyperflow and with the second phase with 4 hyperflow, then we reach even better performances, and thus improvement, we enable to open more advanced satellite services like search and rescue. So here is a summary of this incremental approach. We can deliver first high-performance element in 2017, in addition of commercial satellite, and we can have the final configuration with 4 high-performance satellites in 2020 in order to deliver full services for the end users. So as a conclusion, what this hybrid system composed of 1, 2, 3, 4 high-performance satellites and commercial combined with commercial satellites is the most cost-effective operational solution. It offers high performance, it meets the user requirements, even in the most demanding areas, and it's, of course, what we propose is an attractive and flexible procurement scheme because of this incremental approach. This incremental approach will cover the space and the ground segments, and will provide to EU a full system that, of course, will benefit for an integrated maritime policy. Thank you for your attention.